Okay. Uh, Good evening, everybody who's in India, and good morning to everybody who's in the US. Thank you, ma'am, for the quick introduction. So our goal here is to help facilitate a kind of a medium to start talking to alumni in civil engineering here in the US, so that if anybody is interested in pursuing a career here, you can always reach out to us and discuss more. About me, I'm Ashfaq Syed. So I did my bachelor's from CEG in 2010. I was a middle bencher. I was part of NCC Navy for 2 years. I was a civilization coordinator as well. I did my master's from Texas A&M University in 2014 in structural engineering. I was acting president of the Structural Engineers Association of Texas in a student chapter, and I was also a teaching assistant for computer-aided design. About my work experience, I've actually worked for 4 years in India in the oil and gas sector with Engineers India Limited, where I did mostly structures associated with the onshore refinery and petrochemical complexes. And back in here in here in the US, I work for a company called Datum Engineers. We do a lot of commercial buildings such as healthcare, education, worship buildings, and parking garages. And I've been involved with a lot of parking garage design. So just to give you a quick summary of the responsibilities as a structural engineer, the major responsibility is to provide a system that is safe and efficient, which not only fulfills the client need, but is also provides safety for the general public. And my roles as a structural engineer are divided into 4 parts. First is the engineering. We perform analysis and design of various structural elements for beams, columns, slabs, foundations, and other miscellaneous items. We coordinate with various stakeholders and participate in review and design meetings to make decisions that would aid or affect the structural integrity of the project. We also do project development. We develop the structural general arrangement drawings, details, calculation reports, job specifications to document things that need to be done by the contractor and documents that the contractor needs to follow during construction. And also we do construction administration, which is during the construction phase, where you review the fabrication drawings and you respond to the contractor questions, and also do kind of field observations to resolve any kind of issues that you find. So as a civil engineer, it's really cool that you're able to actually visually see your final end product. Below you can see that there's a 3D model of a church building that I designed, and then on the right hand side of it, I can actually see the actual building being constructed. Onto the right of it, this is a 30-foot long structural steel canopy that I designed for a parking garage in Colorado. And above that, you can see the 3D model of the same canopy. So the biggest, I think the biggest benefit of being a civil engineer is that your projects are huge and they are visible to the entire world to see.
All right. Hello, everybody. My name is Adithya Ganapathi Subramaniyan. I graduated with Ashfaq from CEG, class of 2010, and I did my civil engineering as well. Then immediately followed by that, I also pursued my master's in civil engineering, focusing on construction management at Texas A&M University as well, class of 2012. And my focus has been primarily in the building information modeling side. which I will touch on in more detail in the subsequent half of the slides. Then also, as a part of my master's thesis, I worked on a research project, a fully funded research project that involved in the development of what we call as a BIM cave. It's actually a automatic immersive virtual environment that people could use to see the 3D models. And I was instrumental in working with the professor and developed the whole system for that. And yeah, that's a really interesting topic. And if you guys have any questions, happy to take it offline if you want to reach out to me. And then if we go to the next slide. Thank you. So my work experience, right after my bachelor's, I immediately started my master's. So I don't have any work experience in India, but first job was with component assembly systems. So I did a short stint with them for almost less than a year. So they are a large scale commercial drywall subcontractor based off of East Coast. And they focused on primarily commercial, higher education, and federal projects. So one of the buildings that they did was the Freedom Towers. That's on the photo here. So my role was a BIM engineer. I focused on drywall detailing, and I also helped with the mechanical, electrical, and plumbing systems coordination with them. In short, it's called MEPF. And my bigger portion of the work experience come from DPR. Started with them back in 2013, and DPR is a large-scale commercial general contractor, and their focus is primarily on higher education, healthcare, life science. Sorry. Okay, healthcare, life science, and advanced tech projects. The mission critical is more like data centers and stuff like that. So my focus with DPR has been primarily with the life science market. And one cool project I did with them was the Apple spaceship. That's the photo below here. And that was my first project ever when I started with DPR. And I was on the project for about 2.5 years, managed BIM coordination for all their office spaces. So that's definitely a good experience to start with, pretty overwhelming, in fact. If we go to the next slide. So quickly touching on roles and responsibilities as a construction manager, what the expectations can be. So basically the construction follows a design. Ashfaq touched on the design aspect. So at the core, you need to be a good builder. You need to understand how the building systems go together. So there is no shortcut, and there is no easy way to learn that. So the only thing is you have to actually be on projects and see how buildings get built. And as you go through that, the technical aspects of a building, such as how a mechanical system works, the electrical and plumbing, those aspects, it will be key to know how those systems work. Then you also will be touching on the procurement and the pre-construction, which is mainly the planning aspect, how to get the right trade partners on board, and how to enable the successful project by having the right partners. Then the project management aspect primarily deals with managing the schedule and the cost component of the project. This is almost the most important aspect of being a general contractor. Then the planning phase primarily involves, like I touched before, the subcontractor buy-in, procurement management, and also design management sometimes in a design build contracts. Then the financial management is also a key component, managing the cash flow, the billings, and etc. Then virtual design construction is rather a new aspect that is expected off of construction folks these days, and that involves how to use the 3D model for construction and coordination purposes. The quality control and safety aspects are also just as important to be a successful manager as well. With that, I'll pass it over to Vijay.
Thanks, Adithya. So I'm Vijay. I graduated with a bachelor's from CEG 2011. I was part of NSO because I failed NCC Navy. I was also involved with Civilization 2010. Right after my bachelor's, I went for my master's. Graduated in 2012 from SUNY Buffalo. where I was a teaching assistant for 2 semesters. So I was there for a year and graduated in 2012. So right after graduation, I worked for a company called Resource International, which is a local consulting company in Columbus, Ohio, where I primarily worked on infrastructure work. On the left, you can see a picture of a drill rig in the middle of nowhere. So that was one of the projects I spent almost 2 months on. And I also spent a lot of time drilling in the middle of highways. So I pretty much drilled on every interstate in Columbus. After Resource International, I moved on to Langen Engineering. I've been working there since. Um, with Langen, I primarily work on mixed use developments in urban environments as opposed to um, city and state work, away from urban environments. So on the right-hand side, you can see a picture of me in a busy construction site. I'm actually standing in the middle of 6 of those huge rigs and 2 cranes. You can see 2 of those in the picture, but there are a few around me, all around. What do I do as a geotech engineer? Primary role of a civil engineer is to find out what's below ground because that's where most of our work is. But the other aspects of geotech engineering are very similar to what Ashfaq described. We design a variety of structures such as foundations, supportive excavation for very deep excavations. In urban environments especially, most structures have 2, 3, 4 levels of basements. So as a geotech engineer, I am expected to design earth retention structures that can hold back the excavation, hold back the soil when we excavate deep down. The other aspect is obviously designing and analyzing and predicting performance of these structures that I design. Once the design phase is done, I prepare specifications for the contractor, someone like Adithya, to come in and build what I've designed. And then during construction, I go out to construction sites and look at how things are built. That's an important aspect of being an engineer and actually seeing, like Ashfaq described, seeing your product come to life and making sure that the contractor is following all the specifications to the letter. And this is a very recent phenomenon, I should say. Um, Geotech engineers have started closely working with structural engineers, architects, and sometimes construction managers, even during construction, to come up with, cost-effective solutions in terms of, saving money as well as saving time for the client. So we work in coordination with someone like Ashfaq and someone like Adithya throughout the design phase and the construction phase to come up with very innovative solutions. So that's my role. Now, let's talk a little bit about what you should be doing when you're in CEG. What I noticed that as a teaching assistant in the US is the curriculum for civil engineers in the US in most colleges, I would say even in even in some of the good ones, lacks a good breadth of knowledge. What do I mean by that? When CEG, you learn a lot of things from, you just don't learn structural geotech and construction management. You learn about remote sensing, you learn surveying, you're in workshop, you do engineering CAD drawings, engineering drafting, hydraulics, environmental engineering, traffic engineering. So we learn a lot of things that most undergraduate students in the US don't learn. So make use of the opportunity to explore the different aspects of civil engineering. Now, as you go on exploring, try to see which career piques your interest and see what your strengths and weaknesses are and find out which career will make use of your strengths the best. And use your time, your summer vacation to do internships and use your semester projects to identify what it is that you like in civil engineering and what exactly within civil engineering you like. For me, The moment I realized I wanted to be a geotech engineer was in my 5th semester when we did soil mechanics and foundation engineering. So you'll always have that moment, just be on the lookout for it. Use the time to attend conferences and webinars. Technology has advanced a lot recently, so there are a lot of conferences and webinars online that you can attend, sometimes for free. Some of these webinars are free for students, and some of them come with a very nominal fee. So try to make use of the time to attend these webinars and listen to industry professionals. Try to be abreast with the latest trends in civil engineering, and also try to network with these people so you can learn from them on how to advance your career. And if you graduate, and when you graduate, maybe these connections will come in handy when you're trying to find a job. And use your time in CEG to advance your skills. We'll talk about some of them in subsequent slides.
So as Vijay mentioned, internships are the most valuable resource that you can use when you are pursuing your undergrad, and that gives you a wide variety of experience that helps you shape up your career. When it comes to some of the skills or some of the tools that you need to learn while you are at CEG, softwares is one of them, because you're going to use a lot of softwares in the industry in order to be able to do your work. So once you've identified which field you're interested in, you should focus on developing specific software skills which are popular in that sector, and it should be done parallel to your curriculum at CEG. Uh, so once you figure that out, you can either do this in person through institutes like CAD Center, or you can do it through online course certifications such as Coursera, Udemy, and things like that. Or you can also look at YouTube videos to learn these softwares. Some of the manufacturers of these software, such as Bentley, they have their own YouTube channels where they post tutorial videos for you to learn these softwares. It's always best to learn diverse softwares. For example, if you're a structural engineer, you want to learn an analysis and design software, then you want to learn a 2D or a 3D modeling software, and then probably a programming language. If you're interested in construction engineering or construction management, you can switch the analysis and design with a project management software like Primavera or Microsoft Project. And I would also highly recommend that you get familiar with Microsoft Excel. It's I would say it's the most underrated tool, but you will use it a lot in the industry. Especially, you should focus on learning the macros and the VBA programming in Excel that helps you automate a lot of tasks. Because if you are in the construction side or the engineering side, you are going to do some kind of data analysis, and the Excel is the tool that you would most probably likely use. I would also recommend that you familiarize yourself with a few programming languages. Programming is definitely making its way into the civil engineering industry, especially on the design side. I have experienced it firsthand on how beneficial it is to be able to develop tools that help you automate tasks and streamline the documentation process and the design process. So it's definitely something that you should look at while you are pursuing your bachelor's in CG.
Okay. Also, the just as important aspect, but mostly kind of put in the back burner for the most part, is the communication, the soft skills, or the professional skills. So the oftentimes we realize we're too late in the game, and we haven't done much homework, because practice to track, to communicate with other people is just as important as the technical skills. So one thing that I would highly recommend is when you are in the undergrad program in CEG, practice these skills, make a deliberate attempt to practice these skills with the people that you're comfortable with. Because oftentimes when you actually start working, or even when you start masters, you'll have to communicate with people that are not necessarily from your country or even the same culture. So take the extra effort and extra mile to break those barriers and communicate with them. So I would start early and make use of the time at CEG, be it participating in seminars or presentations or whatever opportunity you can use, practice public speaking and practice your presentation skills. And by practices, sometimes back when I was in CEG, I used to speak really fast, and people used to point to me that, hey, you have to slow down because people don't follow you, and even record yourself, do whatever it takes to hone in all these skills. Also, well, you will realize when you start working, people management is in fact more important than technical skills in some roles. So how to interact with people and how to understand different personalities and kind of deal with that will be really useful. So start early, start with the people that you're comfortable with. And also, as you get opportunities, try to pick up on some international languages. I think CEG gives you folks the opportunity, and definitely one extra skill set under your belt that you can use, especially when you go to European countries, or even work with clients that are not necessarily from the United States that don't speak English. So we can go to the next slide. So once you have done your undergrad, I believe most of you folks are interested in pursuing. So we can, one thing that when we discussed during this presentation preparation, Vijay mentioned that how the location of a university is in fact more important than the actual rating that it carries. Specifically, when you have like a really top rated university that is located in a very suburban area versus a mediocre university that's located in the heart of a big metropolitan city, the opportunities that you get from the university that is located in a big city is more. You get exposure to a lot of big companies, and getting internship opportunities are exponentially more. So be strategic about where the university is located when you make your selection. And also what the university specific department is working on, as opposed to going blindly off of the rating. If you're interested in construction, look at the professors that are in the field and see what research topics they're working on. If something that rhymes with you and if something that you're really passionate about, then don't worry too much about the actual rating. Instead, look at the department specific or the professor specific aspects, because that's going to help you out better, and that look better on your resume as opposed to saying you graduated from Stanford. So that carries more weight. So the importance to that. And also the funding opportunities as well, because to be frank, masters is not cheap. So make use of the opportunity to reduce that burden. And also you can get exposed to a lot of fun, interesting research projects like I did for my masters. And definitely start talking to the professors early about any potential opportunities. In fact, try to work for free, voluntarily for the professor, and offer to help him out and gain the trust of the professor before you actually get a paid opportunity. That's one way to kind of get yourself into the program. Then also talk to your alumni, like how CEG has a really strong alumni community. A lot of these universities, you can find almost every university that you find, you can find a CEG in there. So connect with them, talk to them, and they will be able to give you the ground zero information more accurately than the Google search or whatever you use. And also, we touched on the professors and the assistantship opportunities. So like I said, do your research, communicate with them, and just convey your interest and get some feedback. Hey, is this something that you need my help with? And just start this communication early when you have narrowed down your university. And also connect with your CEG professors. I mean, you'll be surprised how resourceful the professors could be. And you can get some really good feedback from them as well.
Now you've entered university life. What can you expect? One thing that will hit you first is the freedom to choose your own courses. Now, with freedom also comes a lot more responsibility, because the curriculum is not something that's set in stone. You pick your own career path within the university itself. So you need to be self-motivated. You should learn about the courses that you want to take, work with your practitioner, your course advisor, and figure out which course will help you the most in your career. And also, the other thing that you'll see is self-learning is expected. Not everything will be taught in the classroom. Not everything will be, to use the common term, spoon-fed. So you're expected to do a lot of your own learning. The other thing you'll see is there'll be a lot of homework and assignments and tests that'll keep the pressure on all the time. So when you start your program, you'll see the first week, you'll see that you'll have 12-15 hours of classroom time, but don't let that fool you, because your homeworks and assignments will probably take 2 to 3 times your classroom time to finish. So this is something that I did not realize when I started. So my personal experience is, when I started, I without knowing what the master's program entailed, I took more than I could handle. But luckily, came out okay on the other side. But I couldn't say that for a couple of my other friends who fell for the same mistake. Now, some tips for your university life. Take advantage of the credit flexibility programs. As I said, it's your curriculum is not set in stone. You have the flexibility to choose the courses you want. So do not, um, obviously do not take things that will never help you in life, but take, don't just take, if you're a geotech engineer, or if you want to become a geotech engineer, don't just take geotech courses. Try to take some in structural, some in construction management. These will come in handy when you become a practicing engineer, because you regularly interact with these folks. If you do not understand what they're saying, it's tough to, it's tough to survive in the industry. So try to pick a broad array of courses, and not be don't be too pigeonholed in your own field. Get involved with research projects. So you may get extra credits for research projects. At the same time, you can see it as an opportunity to work closely with the professor, and, as I just said, try to get an assistantship, because masters is not cheap. Try to get involved with your local ASCE student chapters. Each university should have a student chapter. ASCE stands for American Society of Civil Engineers, which is a great way to interact with industry professionals in your own local city or community. And one important tip is, do not work part-time at the cost of your master's. Again, this is something that I've seen with a couple of people close to me. Do not, you are allowed to work 20 hours a week part-time when you're doing your master's, but that doesn't mean you have to work 20 hours and make money, because your master's frankly costs a lot more than what you would earn by working 20 hours. So do not, even at time when it's exam time, when you have too much work, concentrate on studies first, and then part-time next. And last but not least, don't forget to have fun, because masters can be very stressful at times. You'll burn up your kitchen, which has happened to me. You'll go crazy with homework and assignments. Between all of this, don't burn out. Try to have fun. Go out with friends. Watch movies with them. Don't just concentrate on your work. Mix some play into it.
So you've selected your master's program, you're almost up to the completion of your master's. Next thing comes in mind is finding a job after your master's. So finding a job in the US has one key word to it. It's networking. So networking is the best, I would say, the most efficient way of finding a job in the US. There is no such thing as campus placements for international students in US universities. Yes, there are job fairs, there are career fairs in on campus or through various organizations, but they are mostly for international when it comes to international students, they are used as opportunities to network with potential employers and to develop some kind of a professional relationship, so that once there is an opportunity, you are able to connect with them, and that would lead to getting that position. So companies hiring you, you need to realize that they have to pay a premium. They have to sponsor your work visa in order to make you employable in the US. So you have to try to go above and beyond your American counterpart in order to succeed in your job search. Get involved with student chapters. As Vijay said, AAC is a great organization to be a part of. If you're a structural engineer, you can get involved with Structural Engineers Association. And also you can get involved with the alumni network of the university or of other alumni networks that would help you in connecting to the right person for the right opportunity. It will also help you gain professional and leadership skills. Use your university career centers in order to prepare good resumes, cover letters, and they will even help you with interview preparation. They'll do mock interviews for you and give you feedback on what you need to do, what you shouldn't do, and things like that. Uh, Use LinkedIn as an online resource, again, to network with other industry professionals and to gain visibility among your peers. I would mention try not to be an influencer on LinkedIn, but if you are someone who's really into it, then go for it. But always remember that stay away from politics and religion when it comes to uh, putting any kind of post on LinkedIn. The biggest suggestion that I would give when you're doing your job search is be patient. There is no magic recipe to find a job in the US. It's all hit and a miss, and it's basically meeting the right person at the right time and applying for the right job. So try to start your job search as early as possible, and especially if you're graduating, say in summer, you should probably start your networking, serious networking in fall. Don't try to wait for the last minute. And also remember that when you enter the US for your master's program, you enter on a student visa. The student visa has a limitation for how many days you can be unemployed. So if you are unemployed for more than 90 days after your master's program, then uh, you have to exit the country. So when networking on LinkedIn or other platforms, reach out to the middle management, because they are the ones who are doing most of the hiring. The entry level and the principal levels are mostly not actively part of the hiring process. And remember, not everybody gets their dream job first. There are different ways people get their dream job. Some of them get it right away. Some of them have to do some other tasks before they get to the right dream job. For example, you can see Adithya, you can see Vijay. Both of them started from at a small firm, and then they went to a big firm for the dream role. So there's always a stepping stone that you need to look out for in order to get into the industry. So always the first goal should be that you should try to get into the industry first, because after that you'll get plenty of opportunities to advance your career through various other companies. So with that, uh, let's move to the third aspect of what the industry trends are in the civil engineering in the US. So when it comes to structural engineering, uh, I can vouch for the sustainable construction materials is something that's picking up right now in the industry, because the Structural Engineers Institute has set a deadline that by 2050, the construction materials should achieve zero carbon footprint, which means that, so as structural engineers, when we choose our material and how it's manufactured, we can actually help in saving around 200 tons of carbon dioxide every year, which is a big number. So the next item is finite element methods. Rather than doing a stick frame model, is becoming more popular these days with the advanced computing programs that we have, and the computer facilities that are easily available. It helps in optimizing and giving us economical results. The third aspect is performance-based designs. It's becoming popular in high rises, where the client is looking for buildings that are not only withstand earthquakes, but are also functional after major earthquakes. So the prescriptive designs that the code recommends is to prevent loss of life. It doesn't cover the performance of the actual building. So performance-based design enables the development of structures that have predictable performance subjected to a definite set of loading patterns and behavior. The next item is parametric design and visual programming. So this is part of the building information modeling system, wherein, so parametric design is like an algorithmic design wherein you set a few parameters and rules, and based on that, the computer gives you or generates a structure or generates a model that you can use to do your analysis and design with. Uh, the next is about structural restoration and forensics. So almost 40% of the projects that I've worked here in the US are about using existing buildings and adaptive reuse or addition to existing buildings, which will require you to understand or interpret the existing structural system, determine its capacities in order to figure out if it's safe enough to handle the new occupancy. Structural health monitoring and non-destructive testing are some of the common areas of research when it comes to uh, your master's program. You'll find a lot of opportunities in these two areas in various universities in the US.
So with respect to geotech engineering, first let's talk about investigation methods. I'm sure if you did soil mechanics and foundation engineering, you would have heard about SPTs. Some of these investigation methods are decades old. There's 50, 60, even 100 years old. There are a lot more new methods that are coming up. So try to keep yourself updated on those. And there's always scope for improvement. So some of these methods are just an improvement of earlier methods, and some are path breaking. So you can concentrate, look into research in those areas. And the other aspect is quality assurance. Back in the day, if you drilled a drill shaft, pile foundation and rock, people practically went inside the holes to look at the quality of rock. Things have obviously advanced a lot over the years, but people are now, engineers and scientists are coming up with very innovative methods of doing non-destructive testing and quality assurance of the things we build. So that's something, again, you can look into. It's a very fresh area of research. And the third aspect is you'll see that geotech engineers have always been using allowable stress design methodology. We are finally catching up to structural engineers. We are moving on to LRFT design methodology. So be very proficient on this new design methodology. Ashfaq already talked about performance-based design, that whatever is in structures generally translates to geotech engineering. And recently, people have started using numerical analysis tools because computing is getting faster and faster. It can computers nowadays are able to run very big programs. I very recently ran a numerical analysis with 1 million nodes, which would have been unthinkable 10 years ago. So um, keep yourself updated on the latest numerical tools and softwares. Um, and then integration of foundation structural design tools. So 10, I would say even 5 years ago, the software packages that you would see in the industry were catered towards either geotech or structural or some other engineering field. But now the new tools are coming up that can integrate all of these aspects into one big analysis tool. So that's one of the latest developments. And the last thing is coastal resiliency. With all the talk about climate change and rising sea levels, coastal resiliency is becoming a very big aspect of what civil engineers do. Most of our big cities are on the coast. Chennai, for instance, New York is on the coast, all of California, most big cities in California, Florida. These have a very big uh, the rise in sea levels have very big impacts on these cities. So that's a new field, an up and coming field that you can probably look into.
All right. And finally, just talking about few of the latest development in construction industry. So one thing that I mentioned before is the building information modeling, or BIM. There's a lot of industry names for this one. So in short, what it is you're creating a 3D model of the building. So before the construction and during the design phase, and using that information, starting from performing the structural analysis that Ashfaq touched on, and the construction industry heavily leverages this model for making sure everything fits before we actually go out there and build. So what we perform is something called as a clash coordination or clash detection. We run these analysis between these thousands and hundreds of thousands of components in the model, and find out where the conflicts exist, and address those conflicts in the model. And so when these duct materials or the walls or the beams show up on site, these clashes are already resolved, so that you're not fixing them in the field, which will cost time and money. So that I would say there are a lot of courses when you go to the masters that will focus on this one. So pick up on those skills, and that will really stand out on your resume, and also will help you when you start working as well. The next one is the high performing buildings. So this is definitely catching up with the sustainable and being a responsible builder, being a responsible designer. So the LEED green buildings, I'm sure you've heard of this before. This is kind of an age-old thing right now, because a lot of states in US also catching up to this LEED standards now, and it's being mandated as we speak. So focus on what is the state-of-the-art materials, and also construction. How you build a building also contributes to a lot of carbon footprint. So the contractors are becoming socially responsible to see how they can minimize their carbon footprint as well. And the third one is the lean project approach. So with construction, as you're trying to eliminate waste on the material and what you use for the construction, that typically there is a lot of waste in terms of the resources and the time spent. So this lean project approach focuses on how to optimize your team's performance. And there are a lot of methods. One is the integrated project delivery method. To do some more research on this one. A lot of US based companies are adapting to these contracts now, where the designers, the owner, the contractor, and subcontractors are all in this shared incentive pool. So if they contribute to the success of the project, everybody will get a physical compensation for what they're achieving. So as opposed to people looking out for their own little companies, everybody is looking out for the project as a whole. So this is has been a really successful approach in these days. And also the design build projects is another method of contracting. So traditionally what happens is the owner hires a designer, and the designer and the owner hires a contractor, and they manage both of these entities. So they have realized to cut the middleman, and they have the general contractor kind of hire all these design partners and the contractors. And this approach is proving to be more efficient, cost efficient, and also avoiding a lot of conflicts and misinterpretation in the design documents. So that is also a latest trend that's catching up. And the last 2 points, I'll quickly touch on those things. Laser scanning is a cool tool that people are starting to use. So like Ashfaq mentioned, 40 to 50% of the projects that we work on could be existing buildings, and trying to capture the good data from these buildings is really important, because the as-built drawing that you get from the developer is usually not correct and it's not up to the standard. So trying to use this tool to capture the data will be useful during the model coordination. And finally, robotics in construction. I mean, sounds just as futuristic as I've heard 5-10 years back, but now the industry is catching up to it. They're trying to leverage how to automate some of the manufacturing of construction material, and even building most of these components offsite, and just install them on site like Lego blocks. So this is proving to be a lot of there's a lot of future in this field as well, that many companies are catching up. So that's the construction trends. That's pretty much it. And
So
I think we allocated some time for questions, right? So feel free to bring up some stuff. There's a lot of content that we threw at you guys in a short amount of time.
So we do have a question.
I think it's more for Adithya.
What about 3D printing? Is that
actually, that's a cool? Yeah, I think that's a cool topic. So we've used the project that I worked on in Apple, the spaceship building. So we used 3D printing in a slightly more creative way. We actually 3D printed the whole building in a small scale model, and we used that we printed like little cranes, little people, little trucks, and we actually used that to coordinate site logistics, and also to see if a crane is going to swing from left to right, is it going to interfere with a certain work area. So we did that. But actually 3D printing an actual real building is still more of a research topic than a more good practice. But there are some components that could be fabricated using robots. I think DPR does wall panels offsite. They actually model these walls right from every single components that go into it. These robots can actually take the model and fabricate and weld, and they do everything automated. So this is not exactly 3D printing, but they're using a robot to kind of make these components that would be traditionally stick built in the field.
I would add to what just Adithya said. So there's a company called Icon Build. I can type the name of the company. So they did a prototype of a 3D printed house in Austin, Texas, and their goal is to and their market segment is for affordable housing. From a general industry perspective, 3D printed buildings are still has a long way to go, but I do see some potential for 3D printing in the low cost housing sector, where you want to save as much money as possible and just build something that's really cheap. But still, to be mainstream, it's going to take a few more years. And I know there are a few universities that does do research on the materials that are being used for 3D construction, 3D printing construction.
The other important aspect is modular construction. I think that's something Aditya touched upon. So these are just blocks of houses that they build in a factory, mostly done by robots. And they bring them on site and just stack them one on top of the other. And they have some special connection details that hold all of these Lego blocks together. But the construction duration for a typical building of that size, if it takes 6 months, this whole structure can be built from ground up in a matter of a week or two. So that's also one of the latest. We are actually working with a developer in New York City on a new type of modular construction that'll save. Usually with modular construction, the most amount of time goes into foundations, because foundations are generally very rarely prefabricated. But we are working with a developer in New York City who's looking into modular construction for foundations as well. So that's something new, and I think we'll see that more in the coming years.
If anybody wants to turn on their mics to ask questions, feel free to do
Shall I
so.
unmute everybody so people can
Sure.
ask? Ask all to unmute.
Am I audible?
Yes.
Yes.
Yeah. So I have a question. So this is related to the lead green associate. So I just want to know more, and I just want to know if it's going to be worth getting the certification. I mean, the accreditation.
I can speak to that. I just
Yeah.
completed my green associate exam like 3-4 months ago. I would definitely say yes, go for it. It has definite value. So it has a global value actually, and people, our industry, since people are more aware about sustainability and reducing their carbon footprint, a lot of companies are looking into these certifications and making sure that they have potential employees who are well versed with the sustainability aspect of things. So I definitely give a thumbs up for the LEED certification.
And even for the students, like
Yes.
I'm just in a kind of way. So.
Sure. A green associate, you don't need any experience to give your green associate exam. And you can do it as a student. In fact, I was wanting to do it when I was in my bachelor's program, but I think during that time it was called IGBC, Indian Green Building Council, had a different certification. So I ended up not doing it and waited this long to do it.
But with the validity is just like 1 year, right? So how is it?
So no, in order, so you need to do continuing education in order to keep it valid. So you need to take, I believe, 15 hours of continuing education for within 2 years of getting that getting the certification in order to keep it active. So that is something that you might need to invest on. And usually companies pay for those education courses for you to keep your license active.
So there is a question from Fardeen. What is the average pay for a full-time job for a civil engineer in the US? Even a rough figure would be nice.
I can
would say
start.
the.
Oh, sorry. Go ahead.
Go ahead,
Aditya.
Vijay.
Okay, so I can give you my personal experience. Average pay varies significantly. That's the easy answer. It changes with the area you're working in. A person working in New York City with a very high cost of living will obviously make more than someone who works in West Virginia or in the South, Kentucky, Tennessee, where the cost of living is comparatively less. So cost of living plays a very big role in the pay that you get. But on an average, I would say a starting salary for a civil engineer, not in a big metropolitan city, will be around 60,000. If you're in a big metropolitan city, you can look at 75,000. This is for an average, not an average. This is for a standard consulting engineering consulting job. But if you're going into more specialized fields, there are very top of the class civil engineering companies that do very specialized work that are not in general consulting. There, your salaries can be upwards of 150,000. but that is a very, very narrow field, and they mostly look for someone with PhD in that narrow field. So if you're into, if you're after money, then I would say you should start looking at some of those very narrow fields that offers these high-paying jobs.
Nasia has a question. What can I expect the average fee for masters to be with and without funding?
With so average fee for masters is also a wide variety, right? So right from just like in India, how you have a CEG, which is really affordable, to a private college that's very expensive. The variety is quite a bit. But I can speak to the experience that I have. Texas A&M is considered to be one of the most affordable universities. So without funding, you're expecting to spend anywhere around $20,000 for the whole program, just for the tuition and the fee for the college. The living expenses outside that. But when you get funded, they take care of 100% of your tuition. You just pay the small percentage of the administrative fee. If you get fully funded, you're barely paying a few $1,000s for the whole program. But that again depends. Sometimes you don't get fully funded. You can get partially funded. You can get actually paid a salary as well. So, but the Texas A&M is on the cheaper side. So when you go to Penn State and bigger universities in Pennsylvania, you could be spending $40,000, like twice as much.
I can add to that, since I recently finished my master's back in 2014. So I paid close to 7,500 per semester for just the tuition. And on an average, you'll spend around, say, $500 a month, including rent, utilities, and groceries. So I think the per semester cost, even at Texas A&M, has gone up to close to 8,000. And this is for a 9 credit hour semester. So I would say around 40,000 US dollars is something that you can expect to pay if you don't get any funding. But in most instances, people do some kind of a part-time job, either 10 hours a week or 20 hours a week, to at least be able to cut down the monthly expenses on monthly personal expenses, I would say.
And the other thing I would add is, if you're in a metropolitan city, if you're in New York City or in a university in, like, let's say Chicago, your cost of living goes up considerably as opposed to a small college town. So that's something you should be looking into.
Other questions? Anyone?
I have one more question.
Go for it.
Yeah. So I want to know, like, how did you guys choose like a particular field for the masters? Because there are plenty of things I'm interested in, like, as of now, and the mind keeps wavering. And yeah, and particularly there's no, like, apart from the interest, we don't get to get experience on each and every field, right? So to get to know that if you're good at it or no. So how to select on it?
I mean, I can start with that. So one thing I would say is, yeah, there are a lot of these different subdivisions in civil engineering, but at the core, you can think about it this way. Think about it whether you want to be on the design side or on the construction management side. So just to try to answer that question first, if you want to be more on the design side, you can think about what Ashfaq is doing or Vijay is doing, which is either some aspects of the design. But if it's more on the construction management side, if you're like really interested in managing projects, how buildings get built, the cost and the schedule, then you're probably more thinking towards management. So first try to narrow down what aspect, then you can drill down. Okay, if you're interested in design, what aspects of design, then you can hone in further on your selection.
Yeah, go ahead, Vijay.
Okay, so the way I picked geotech was, as I said, fifth semester, fourth semester internship was somewhat related to geotech engineering, and then fifth semester I had soil mechanics and foundation engineering. I had Muttara ma'am; she was amazing. So that really got me interested in geotech, but that was not it. I also participated in some design competitions. So I got the chance to work on a almost real life, I would say, design project. So I, I did two competitions, one in structures and one in geotech. And for some reason, geotech clicked with me. So also it depends on what kind of a person you are. Just like Adithya said, if you're more a people's person and a management person, I think you'll find your role in construction management to be more geared towards you. If you're more into crunching numbers and um, crunching numbers, then you'll find design to be more suited towards your personal growth. Um, yeah, that's about it.
Uh,
You want to add?
sure, I would add a quick uh, item is that first figure out what you don't want to do. If you know what you are really not interested in, then it'll be easier for you to kind of shortlist things that you can explore and use internship opportunities, or just talk to people who are working in that industry to figure out what actually they do as a structural engineer or as a geotech engineer, and then see if you think you want to do this or not. And there's nothing wrong in starting in a program, or starting in a field that you initially think you like it, but then switching to something else. It's completely okay to do that. There's nothing wrong in exploring different fields. So and especially after you graduate, the first few years are for you to kind of figure out where you want to be. A lot of us are not that lucky to be really confident on what exactly they want to do in the next 5 years. Some of us have to kind of juggle around to see where they fit well. And the best way to do that is through internships or through taking jobs.
One thing I'd like to add is if our college professors work with a lot of consultants, so maybe you can ask professors if they can talk to some of these consultants, and you can shadow these people for a week or two and see what they do, see if you like it. If you spend every minute with one of these engineers in different fields of engineering, 1 or 2 weeks, you'll get a good understanding of what they do and see if that's something you want to do for the rest of your life.
Awesome. Shall we wrap it up?
Sure, if there are
Okay.
no questions.
Thank
And
you.
so
Yeah, thank you so much, Adithya, Ashfaq, and Vijay. This was a very, very thoughtful presentation. The three of you worked together so well and so thoughtfully to put together this webinar, which touched all the aspects of starting from preparing to enter a university in US, how to enter the university, how to take advantage of what's being offered, and then how to get into the job market and how to land a job that you like. And I really appreciate the amount of effort and thoughtfulness that have gone into it. I'm sure everybody who attended the program here benefited tremendously. And so thank you so much. And thanks everybody who attended. I hope you were able to get some of your questions answered. And with that, I think we are at the end of our program. Thanks everybody.
Take care, everyone.
Bye-bye.
Thank you. Bye.
thank you.